Good morning or afternoon. Today we're going to start by reviewing the basic building blocks for Algebra 1 that you've mostly should have previously learned. We're going to start with some vocabulary here that you need to know. There's a lot of vocabulary in Algebra 1, and for some people it seems like a foreign language. So first off, we have a coefficient. A coefficient is a number that is multiplied to a variable. It includes the sign. Oops, could have left some space. So, for example, if we have something like negative 3x squared, then the coefficient of that includes the negative. So it's negative 3. So even if we had something like, so that one goes there. So even if we had like 4x minus 3x squared, then the negative still goes with the 3, so the coefficient is negative 3. And for this, of course, the coefficient would be 4. So that's a coefficient. A constant is a number that cannot change value. So see, here we have variables involved, and so the value of each term can change, which we'll talk about what a term is in a minute. So a constant is a number that does not have a variable. And again, it's called a constant because it's a specific value always. So again, it has no variable. So for example, if we just saw 12, 12 is a constant because 12 is always equal to 12. A variable is a symbol that we use for an unknown value. You are mostly used probably to using X or Y. It could be any letter, symbol, anything. A smiley face, in effect, could be a variable if it's standing for an unknown quantity. So the most common ones we use are X, Y, and T, T for time. And then in function notation, we might have something like f of x, where it tells us that x is the variable, the independent variable, meaning it's the one that we will input values for. F of x is the same thing as y, it's just a different way to write it, and f of x would be the dependent variable, as is y in most cases. Terms are any set of values, actually any value, singular, or variable, including its coefficient, separated by pluses or minuses, or equal signs if we have an equation. And then there's one term that's not written down here, and that would be degree. The degree refers to the highest exponent. An exponent is another word for power, or combination of exponents, meaning sum, adding them up. In a single term. So if we look back up to the green, where I wrote up here 4x minus 3x squared, the degree is 2 because the highest exponent that we have is a 2. This, of course, is x to the first. So the degree here would be 2. The next basic thing we need to look at is order of operations. And order of operations, the way you normally use them is when you are evaluating. And if we're evaluating, we work our way down the list. So it would be parentheses come first, exponents come second, multiplication and division working left to right would come next, and finally addition and subtraction, again working left to right. In the next video after this one, you're going to be solving, and when we're solving, we're doing inverse operations, which means basically we are doing the opposite. Therefore, we are going in the inverse or opposite order. So if evaluating is going down the list and doing things in that order, when we get to solving, we'll be going the exact opposite direction. In other words, we'll be inverting it and doing the inverse operations or the opposites of each thing. So if we look at a couple of examples, we have negative 3 times the quantity 21 minus 28 plus 18 divided by 3 plus 2. Now, this is the order again that we do it in, starting with parentheses or what's called grouping. So we have this grouping here. You can do multiple steps at the same time. In other words, this grouping here is separate from this, and the next thing we don't have any exponents, so we would go to multiplication and division. So this we could do in one step. We could do both of those things at the same time. I'm not going to in this case, but if you feel more comfortable doing that, that is fine also. So we would then have negative 3 times 21 minus 28 is negative 7. I'm going to leave for now the 18 divided by 3 so that I can show the left to right part of multiplication and division. Now we took care of parentheses. There are no exponents. We're down to multiplication and division, and we should work left to right. So negative 3 times negative 7, negative times negative is positive. 21. We have the 18 divided by 3, which is 6. And then we have the plus 2 at the end. We've taken care of the first 3 sets of things. We're down to addition and subtraction. And again, we work left to right. Everything here is addition, which makes it easy. 21 plus 6 is 27. Plus 2 is 29. So our answer is 29. In the second example, we have all sorts of things. We have parentheses. We have what are called implied parentheses, meaning the 8 plus 17, because it's all inside a square root, that is considered to be in parentheses, even though we don't tend to write them. If it helps you to write them, that's fine also. So as we look at this, can't do anything with the 11. We can't do that subtraction. 11 minus 7, because 7 is multiplied and multiplication comes before addition or subtraction. We're going to leave the 7 alone because we've got this to do. We have 1 plus 3 is 4, and then that is squared. And then we have 8 plus 17 that are implied parentheses, and that gives us 25. So now we need to take care of exponents. So again, the 11 doesn't change, the 7 doesn't change. 4 squared is 16. We can go ahead and do the square root of 25. A square root just means what times itself gives you 25. So 5 times 5 is 25. So the square root of 25 is simply 5. Now we've done parentheses and exponents. We're down to multiplication or division. 7 times 16 is the next thing we need to do, or negative 7 times 16, whichever way you want to look at it. 7 times 16 is 112. If you need to go off to the side and write it out and do the multiplication and actually do it this way, you get 42, carry the 4. 7 times 1 is 7, plus 4 is 11, and there's your 112. And then we have the plus 5. Now, in theory, you're supposed to do addition and subtraction left to right. Some students find it easier to do all the positives together, all the negatives together, and then get a final answer. I will leave that up to you. So if we did 11 minus 112, that would be negative 101. Because 112 is bigger than 11, so the answer is going to have that sign, which is negative. And then adding 5, going right 5 from negative 101 puts you at negative 96. So our answer would be negative 96. The next thing we're going to look at is combining like terms. Like terms have to have the exact same variables. And the exact same exponents. And this is where, if you have highlighters or colored pens, some students find that helpful because they can just go through and highlight all the ones that look the same. So for example, I can see I have a negative 12x cubed, and going across I have another one, a negative 9x cubed. I only have one x to the 5th term, that's right there. I have a couple of x squared terms. And I have a couple of x terms. And I did something on purpose that you need to be aware of. If you're going to circle them because you don't have highlighters, be careful. Is that a plus or a minus with the sub and x? Because when I circled it, I went right through it. Notice on the other ones, I avoided that. So if you go through it, you probably should go back and darken it back in so that you know that that is in fact a plus. When we write our final answer, we want to write it in what is called descending order. So we want to go highest exponent to lowest. Especially when there's only one variable. So we didn't have any other x to the 5th term, so we have 4x to the 5th. So that one's done. We have a couple of x cubes. We have negative 12 and negative 9. We are adding, so we have negative 12 of that and negative 9 of that. It's still the same thing, so the exponent does not change. It's x to the 3rd still. Negative 12 and negative 9 make negative 21. So we've dealt with the x cubes. We have x squareds. We have a 19 of them and negative 3 of them. 19 minus 3 is 16, so we have 16x squared. And then for our x's, we have 7 of them and 32 of them, both positive. 7 and 32 make 39. So there's our answer in descending order because it goes exponent of 5, exponent of 3, exponent of 2, exponent of 1. In the second example, we have multiple variables, so they have to be exactly the same variables with exactly the same power. So this has an x and a y squared. That has an x squared and a y. That has an x squared and a y, which is not the same. And then we have the x and the y squared again. So we have 3 of them minus 13 of them. 3 minus 13 is negative 10. And we have an x and a y squared. And then we have the two middle terms that go together. Notice the first variable here is the x squared, so this term should come in front of the second one because the x is first and this has an exponent of 2, this has an exponent of 1. So in theory it should go in that order. A lot of times instead of reading negative 9 plus 24, it's easier to read it backward and say 24 minus 9. 24 minus 9 is 15. So our answer to simplifying this, or combining like terms, and again, notice up here in the bold, it tells you simplifying is the same thing as combining like terms. Sometimes you'll have some multiplication to do, distributing, which is the next thing we're going to talk about, but we're assuming here that everything had already been distributed. The next thing we're going to talk about is the distributive property. And to distribute simply means to multiply everything inside the parentheses by a number or term that's outside the parentheses. It doesn't matter whether the number is in front or behind. So this would be the same thing as if it were written this way. So if it was 3x squared minus 7x plus 11, and then we had parentheses and a negative 8, that still says multiply. So you need to be aware that sometimes the number you're distributing is after the parentheses. Okay? So we just need to multiply each thing inside the parentheses by negative 8. Again, there's no x out here, no variable that we're multiplying by, so the variable parts won't change, just the numbers or the coefficient and the constant will change. Negative 8 times 3 is negative 24 x squared. You need to be careful when you're distributing a negative not to lose track of signs. We have negative times negative is positive. 8 times 7 is 56, and then we have the x. And then negative times positive is negative, or the opposite of positive is negative, whichever way you want to think of it. 8 times 11 is 88. And again, if the terms weren't already in descending order, we would want to write them from highest to lowest. It was already that way, so we don't have to worry about it. In the second example, we have fractions. So when you're dealing with fractions, what you need to realize is the line in a fraction. So we have the 3/2 there. That line, of course, simply means divide. It is, in most cases, easier to divide than multiply by the smaller number when you go to get your answer. So, and this time we also have a variable. So this is an x to the first. So that means we're going to get another x. So like here there are 2 x's, so when we distribute there will now be 3 x's, meaning it will be x to the third power. When we distribute the 4 with it, we go 4 divided by 2 is 2, times 3 is 6. So our first term is 6x to the third power. For the next term, we have 1x outside, and there's 1x here. That makes 2 x's, or in other words, x squared. It's going to be positive. And now we can deal with the number. 4 divided by 4 is 1, times 5 is 5. The last one we have negative times positive is negative. And then we have 18 times 4, which is 72. And because we're multiplying by that x, it just goes at the end. And so our answer to this problem would be 6x cubed plus 5x squared minus 72x. And that's the distributive property. The last piece for the introductory stuff is evaluating expressions, which simply means, evaluate means to plug a number in for a variable and determine a numerical answer. So there's 2 ways it can be written. One will say evaluate something, an expression, because there's no equal sign, it's an expression. And then they'll give you values for any variables. The other way is what is called function notation, which I mentioned earlier. And so what you'll notice with function notation is this time we have an equation, and it says f of x equals 3x cubed minus 7 over 2x plus 11. Notice that now it says here to do f of negative 2. So this is the same thing as telling you x is equal to negative 2. And so everywhere there's an x, we would plug in a negative 2. So that's just two different ways to write it. Completely written out or shorthand, which is called function notation. So going back to the first problem, we need to plug in a -3 for all the a's and a 2 for all the b's. When you plug them in, you always want to make sure that you are putting them in parentheses. So a is -3, so I replace that a with a -3 so that it now says 3 times -3 squared, because a is -3, minus 2 times a is -3, and then we have b to the 4th, b is 2 to the 4th power. Then we have 6 times b, and b is still 2, and then we have minus a, which is -3, times b, which is 2. And now we're just back to order of operations. So, because exponents come first, we're going to have 3 times -3 times -3 is positive 9, minus the 2 times the -3. And you have two choices here. You could actually, again, do the 2 times the -3 now, but I'm going to do it in 2 steps. We need to multiply whatever that answer is by 2 to the 4th. 2 to the 4th power is 2 times 2 times 2 times 2, which gives us 4 times 4, or 16. And we could go ahead and simplify the rest of this. 6 times 2 is 12. -3 times -2 is -3 times 2 is -6, but then we have this other negative out here, which means opposite. The opposite of -6 or -6 is +6. And now we can just simply do the rest of the multiplications and add up our answers. 3 times 9 is 27. -2 times -3 is 6. 6 times 16 is 96. And again, if you needed to go off to the side and do 6 times 6 and get the 6 and carry the 3 and get 96 that way, that's fine. Then we have a +12 and a +6, which we could have gone ahead and added up. So now we need to add all this up. 27 and 96, that part's 123. 12 and 6 are 18. If we add the 123 and the 18, we get 141. So there is our answer. In the second one, in function notation now, again, the f of -2 tells us x is equal to -2. So f of -2, and you need to write that down because it's written that way, is equal to, we have a 3 times x is -2 cubed minus 7 over 2 times x, which is still -2, plus 11. So notice we filled in the -2 for every x in the problem. You don't, as long as you write an equal sign, you don't have to keep writing f of -2 each time. -2 times -2 times -2 is -8, because -2 times -2 is +4 times the third -2 gives us -8. We have a -7. In the denominator, we have 2 times -2, which is -4, plus 11. In the numerator, now we can multiply the 3 and the -8 and get -24 minus 7. In the denominator, reading it backward, 11 minus 4 is 7. And then -24 minus 7 is -31 over 7. That is your answer. Do not pick up a calculator and punch it into a calculator, because that will give you an approximation, not the exact value. If you don't like improper fractions, you can write it as a mixed number by saying 7 would go into 31 4 times with, why did I put a parenthesis? Sorry, I meant to put a fraction line. With 3 left over. So ignore that, sorry. So it's the same as -4 and 3/7. But this answer is perfectly fine. I would leave it -31/7. It gives you less likelihood that you would make a mistake. If it's a word problem or an application, most of the time we would give it as a mixed number, or we would give a decimal approximation. So those are the basic things that we need to know in order to do and begin Algebra 1.